All right, hello everybody. Here we are, another video, another final video before spring break. Ooh wee. Well, I hope it's the final video before spring break. I can't imagine what I'd have to do it else for otherwise. All right, in the previous video regarding the midterm review, we covered the first 17 questions, aka part one of what will be the midterm in school. The next set of questions, problems 18 through 36, will cover the second half of the midterm, which is about polynomial properties, operations, multiplying, adding, factoring, all that good stuff. And it is good stuff to know. So I get the feeling this could be a little lengthy if I try and explain everything at length, which I mean I want to do, but maybe if there's a couple repeats, I might start going a little faster. We'll see. All right, so first problem, leading coefficient and degree. You should always start by thinking about the degree. Never start by finding a leading coefficient because, well, you can't find it without knowing what the degree is. So the degree is the largest exponential term. For example, the first term doesn't have any variables, so it counts as 0. The second term is 1, 3, and 9. So the highest number of those was 9. That's the degree. The leading coefficient is the number in front of that, so that refers to the thing with the degree of 9. So in front of the term with the degree of 9, not including the w, negative 15 was there. And yes, the negative sign is important. So make sure you choose correctly the proper sign. I will mention that if it doesn't have a number in front, then that represents a 1 or a negative 1, depending on if it had a positive or negative value to it. So please be on the lookout for that, okay? Leading coefficient should be found after the degree. Highest exponent for the degree, leading coefficient, the number that was in front of that term. Problem 2. Add these together. All right, here comes the pen. We're going to be doing a little bit of this today on this one. 6y squared minus 3y minus 7 plus 5y squared minus y plus 2. Notice I didn't bother putting parentheses. It really doesn't matter if you have these parentheses around these. The only time it would take any effect is if there was a minus sign between the two, which there was not. If there was a minus sign, I would have needed to flip all the signs on this second one, but I can't foresee that being an issue. I think by default, you're probably going to very likely be asked to add things. And that's what you do. I add the 6 and the 5 to make 11. Oops, sorry. I was saying the word 5 as I was writing. Don't write 11y to the 5. Write 11y squared. 6y squared plus 5y squared is 11y squared. Because those are like terms, but don't change any exponents. Negative 3y and negative y make negative 4y. And then finally, negative 7 plus 2 is negative 5. There's my completed answer. Yeah, be careful. Don't add any exponents. If you add y squareds with y squareds, the result is y squareds. If you add y's with y's, you get y's. If you add numbers with numbers, you get numbers. Boop. Next problem. This one has 10b to the 5th outside of a parenthesis, plus this stuff on the inside. Now, this looks kind of familiar to us because actually what we had done recently on a test was take stuff inside or like take stuff that was distributed and turn it back into this, although this hasn't been completely factored. Whatever. The point is that was stuff we did recently. We factored. Now we're going back to the old school stuff. We're distributing. So distribute that in here. 10b to the 5th times 9 is 90. B to the 6th because the 5 adds with the invisible 1 there. And then 10 times 3 is 30. B to the 8th, because b5 and b3 add to make b to the 8th. That's part of the exponent properties, which is why we bothered to learn exponent properties before we learned the polynomial stuff, because sometimes in polynomials, you got to use exponent properties. Huzzah! So just multiply whatever's on the outside into it. Okay, the next thing here, you need to use a slightly different technique. So you have two choices. I couldn't help but notice today that almost nobody, well, no, I won't say almost nobody. Almost half or less were using the method I originally showed you guys, which was to create a 2x2 box. Now, if you've been doing my stuff lately in class, then we've been using this to write stuff inside the box and make what goes on the outside. That was for the purposes of factoring. But when you want to multiply two things together that have already factored out, you want to multiply them to make something in the box. So v times v is v squared. We get negative 6v. We get 3v and negative 18. These diagonal guys combine together. So your final result is v squared minus 3v. That's what you get when you do negative 6 plus 3. And then minus 18. If you recall from class, what we had done was been given something like this, what is our final answer looking thing, and asked to factor it back into the original. Yes, remember that was the whole point. We're trying to learn how to go forwards and backwards in terms of factoring and distributing. So this was the older stuff, the distributing stuff. Now, if you don't like that, I'll show you an alternate way on the second one here. If you think the box takes a little too much of your time. Here's the FOIL method, a classic. The arrows represent me doing the following: x times x squared, x times negative 7, negative 7x, 2 times x, 2x, 2 and negative 7, negative 14. You'll then add the like terms in the middle to make negative 5x, and voila, you're done. You'll notice you get the same kind of results as if you were doing the box. You get 4 things, you add the like terms together, that are the middle 2 results usually, and it's as simple as that, right? So you can choose. If you want to do the box, you can do the box. If you want to foil, you can foil. I'll do the box guy on this one as well. That way you can have more examples of it. This problem is not much different from what we saw a second ago. The only alteration is that the numbers in front are not just A. They're 4A and 3A. Whoop-de-doo. It's not a big difference here. You get bigger numbers. So again, if you're using the box, write them on the outside. 4A and 1. 3a and negative 7. Keeping the signs is very important. You get 12a squared. Don't forget that a times a makes a squared. 3a times 1 makes 3a. 28, well, negative 28a is what you get here, and negative 7. So your final result will be 12a squared, negative 25a minus 7. The negative 25 is coming from me adding these two guys together because they're like terms. There you go. Again, you could use the box on that. You could use foiling on that. My advice to you, because I did see people trying this today and not being successful 100% of the time, don't do it in your head. I do realize that you could math out in your head 4 times 3, okay, 12a squared, and write that. That's fine. And you could math out 4a and negative 7, that's negative 28, and this stuff makes 3, and negative 28 plus 3 is 25, and put that, and then 1 and negative 7. I get that. It's okay to do that, but I would recommend writing it just to be safe and make sure you're doing it good. Because a single error is a wrong answer, and that's just the facts, man. All right, another one. I'll foil on this one. So arrows, 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 arrows. So 5 times 6 is 30x squared, because x times x, don't forget that. 5x times 5 is 25x. Negative 2 times 6 is negative 12x. Negative 2 times 5 is negative 10. So your final result will be 30x squared plus 13x minus 10. Simple. You know, I was thinking to myself as I saw people working through this in class that maybe I had put too many questions here, but at the pace I'm going, I mean, and I'm explaining it too, of course, that we're making great time, by the way. We've gone through 6 problems in 8 minutes, and that's with me describing stuff to you. All right, the next one has multiple letters, not really a big deal. You do have to remember one thing that I got to mention to you because I feel like people tend to miss it. Now here again, you can use a box, you can use arrows. I'll go arrows. So I got 4a times 7a, that's 28a squared. I got 4a times 5b, that's positive 20ab. I got negative 5b times 7, which is negative 35ab. I do realize that it looks like it should become ba, but BA, AB, it's all the same. It's important that you kind of write them the same so you know that they're like terms. And negative 5b and positive 5b make negative 25b squared. This guy right here, squared. Most commonly missed thing. I see people doing this perfectly right, but they're forgetting to put a squared on that last term because it's a b times a b. It's got to make b squared. I add the middle like guys together. 20 minus 35 is negative 15. And bada bing, bada boom. Like a very large, if you're noticing, a very large portion of the questions so far have been, can you multiply a binomial, a two-piece thing in a parentheses, times another two-piece thing in the other parentheses? Like, can you do that? I hope you can do that. That is very important. Okay, here's another one of those, but it doesn't look like two things. It looks like one thing. I'm going to tell you right now, if you're watching the video, this isn't secret knowledge, it's just common sense knowledge, I hope. This is not x squared plus 36. If you square x and you square 6 and put that, hold on, let me get red here. No, 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 no. You need to do this. You need to do x minus 6 and another x minus 6. That's what the squared means. It means it's the same thing twice. Now, from here, you can do what you want. You can do FOIL, or you could use a box, whatever you want to do. It's been a minute since I used the box. We'll use a box here. Usually when kids ask what I would recommend they do, I say put it in the box. So I'm going to do that here. X squared, negative 6x, another negative 6x, and a positive 36. Very important that negative 6 times negative 6 makes a positive 36. Your final answer is x squared minus 12x plus 36. Yes, negative 6 and negative 6 do not cancel out. They'd have to be opposites, so they combine together to make twice as much. X squared, 12x, 36. That's a special product. Ooh, sorry, I quotation too far away. Special product. I'm like quotationing over here like 3 feet off the screen. This next one's a special product too. If you recognize it, you could probably go get the answer really fast. It doesn't hurt you if you still do the workout regular. The answer will be v squared minus 81. How do I know that so fast? Well, see how there's opposite signs here, but the same stuff? That's called conjugates, and the middle terms essentially cancel out. So I know there's not going to be a middle term, just first times first and last times last. Now, here's the deal. I'll do it out just in case you're one of those people that's like, well, I'm not going to remember that. That's fine. You would get 9v minus 9v minus 81, and then you'd say to yourself, oh, these cancel out. Is it really that much more work to do it that way and get the final answer like this? Nah, not really. So do the workout as any other problem if you're feeling like it, but if you do notice it's special, I guess you can answer it slightly faster. All right, here we are. We have now reached the midway point of the 8th chapter, wherein we went from multiplying and combining them together into one single phrase into factoring them, and we just had a test on this, so I'm hoping these last questions, I think, what is this, 7 of them, are not super hard, but based on some of the test scores, I know some of you have some work to do on this front, so I hope you do it. Do it here and practice it and get good. So what you do is this. You say, okay, what can I divide out of both of these? I want to undo something that multiplied. So I can remove, both of these are divisible by 3. And I saw some people doing this. I'm not saying that's a bad thing to do. Maybe it's a good thing to do. I don't know. Try it. They're both divisible by 3, and they both have n squared or higher. So 3n squared can come out of both of those. So in a final answer, I will write that in front of a parenthesis, and my leftovers will be, what do I get when I divide these things by 3n squared? So I get a 5, and that's it. I just get 5. 15 over 3 is 5. N squared cancels out with n squared. The next one is negative 9 over 3, which makes negative 3. And n cubed over n squared makes n. And that's it. That's the answer. It's factored. I do have some people I'm feeling are like mind boggled by factoring. Guys, I have bad news for you. If you're not a fan of factoring, it's gonna exist the rest of high school. So you better practice it. You better get good at it, and I hope you can show me at the very least, if you struggled on the test, a slight amount of improvement between then and this new thing, or at least if you were good, be consistent, I guess, because I did see plenty of good as well. I saw lots of good, actually. I saw very few not good. The issue was, though, the not goods were really not good. Anyways, I'm putting a box here, and as you saw earlier on some problems, I did use a box, but I wrote the outsides and multiplied them to make the insides. Well, here I'm going to write these as the insides and divide them to make the outsides. And by divide them, I mean, what can I divide out of each thing? Let me start with the columns. What can I divide out of 4v cubed and 20v? They're both divisible by 4. And they both have a v at least in them, so 4v can come out. How about 7v squared and 35? Well, those are both divisible by 7, so we'll take out a 7. How about 4v to the 3 and 7v squared? No number in common, but they both have v squared at least, so I can write that. And on the bottom row, 20 and 35, those are both divisible by 5. I'm going to make it a negative 5 because they're both negative. Now, I kind of lucked out here. My negative signs were all in the same row. it is possible that your problem has negatives in it, and you might not notice that your answer doesn't have negatives. Like if the problem has negatives in the equation and none of your answer has a negative sign on it, you're probably about to be wrong. So please make sure you double check. The most common thing is the following. I don't know how to describe this without giving you like a structure here. Let's say this first number is positive, and this number is negative, and this number is negative, and the last number is positive. The only way that that is a possible answer is if you have positives here and negatives here. So it'll be like sorry, how to describe that? Like 3x minus 7 and v squared minus 2 or something like that. So just be on the lookout for that. If you have negatives somewhere in the boxes, you're going to need at least a negative, maybe 2 on the outside there. You have to figure out what makes it work. Okay? All right, anyways, back to my problem here. Factors into v squared minus 5 and 4v plus 7. Continue. Okay, another factoring one. Now, unlike the first two, the first one I just did when it came to factoring was I divided out something in common on all of them. The second one was there were 4 things, so I had to use grouping, and grouping required me to use the box. This next one doesn't have 4 things, it has 3 things. When we have 3, the traditional thing to do has been to make this x, put the last number on top and the middle number on bottom, and then figure out what multiplies to make 18, but adds up to make 9. The answer here is 6 times 3, and therefore my final answer is y plus 6 and y plus 3. That's it. That's all you have to do. Now, technically speaking, what's happening in the background is because you wrote 6 and 3, you made a box and you wrote y squared, 6y, 3y, and 18. It's like you wrote the problem again, but you turned the 9 into the 2 things that you split it into, right? And then you do like I did on the last problem. Y can factor here, and 3 can factor here, and y can factor here, and 6 can factor there. Oh, look, the answer. Wasn't it easier just to take those numbers and plop it in? Well, yeah, it was. So we don't ever mess with the box on these. I'm just saying that's a thing that's technically going on in the background that you should consider doing. I saw maybe 2 people doing that on the test. I mean, it wasn't wrong. They still got the right answer. It just kind of was a little bit of a waste of time. So I'm saying if it's got 3 things on it, you can do this x, put the top number as the last, negative 20. On this problem, 1's on the bottom because the middle term is technically just 1z. And then I could get positive 5 and negative 4. That multiplies to make negative 20, but adds up to make 1. And the answer is z plus 5 and z minus 4. This isn't always okay to do the answer like this. Like there's situations. The situation is that if the problem has like a squared term in the front that doesn't have a number on it, you can do this. That's when it's okay to do that. That's not always what you're going to get though. So be careful because problems like this exist. Ooh boy. So here, let me write it out. 5y squared. I didn't write out the last one. This one has a number out front, 5, and I can't actually divide out 5 from all this stuff. You should always be checking for that. I couldn't do that on any problems since that first one so far. So what do? Well, 2 extra steps. Extra step number 1 is right at the beginning. You do 5 times 5 on top, not just 5. You got to do 5 times 5. The first number times the last number, okay? Then 26 is on bottom. So what multiplies to make 25 but adds up to make 26? That'll be a 25 into 1. Then I'm going to do, there's different ways to go about doing this. I'm going to show you the bottoms up way because I think more people tend to like that. If you like putting this into a box and then dividing it out, hey, that's a good way too. So make sure you do it, whatever way you're comfortable with. Anyways, you get a 25 here. This is where step 2 comes in. This isn't the right answer, by the way. Step 2 of this extra process, because there's a number out front, is to take that number out front and put it underneath each of these answers. 25 divided by 5 is now what you have, which is 5. And on the second one, you can't divide 1 by 5. So you bring the 5 up front, put it in front of that y, and then remove it from where it was. So it becomes 5y plus 1. And I know that's a little bit of math voodoo there, but it's called the bottoms up way, and it works. I don't know why I'm describing the name to it. I'm assuming if you're watching this video, it's because you watch probably A, anything I've done in class, and B, any other video I've done. This next one's going to be interesting. and it'll show off what I wanted to mention on that last one. So I'll save what I was going to say then for when I'm getting near the end of this problem, because this one's going to be kind of the same process as before, but a little different. So I do first times last. Sorry, I drew underneath this time. I hope you don't mind. That gives me a 20 and a 21. Man, I'm sure getting it easy over here. What multiplies to make 20 but adds it to make 21? Well, 20 times 1, right? Oh, wait, I'm not going to get it easy. Okay, I'll mention it at the end of this one nonetheless, though. So I get 20 times 1, so I put z plus 20. Hey, I forgot to put a z up here, by the way. Oh, well, not a big difference. Z plus 1. And then just like before, there's this number up front, 10. So I'm going to put that underneath. And 20 can divide by 10 to make 2, so z plus 2. And here it can't divide, so I make 10z plus 1. And before I go on to the next problem, well, let me load the next problem and see if it's got what I thought was going to happen here, because there's something I got to mention because I saw it happening on some people's problems. Nope. Okay. Before I start this problem, let me mention something up here for you. Let's say you're doing bottoms up or something, right? Okay. Let me make a good problem here. 4. Okay, this is totally off to the side. We're going to scribble this here. For your knowledge, video watcher, let's say you got 4x squared. And at the end, let's make it a 3. And in the middle here, we're going to make it negative 8x. And if you do bottoms up here, you're going to end up with x minus 2, x minus 6, and both of those end up going over 4. Sorry, I'm cutting steps here. You're going to get 12 over negative 8, negative 2, negative 6. Okay, this is why I'm showing this to you. 2 cannot be divided by 4, and 6 can't be divided by 4, but they both can be reduced. So in this situation, which could happen to you, you do x minus 1/2, like you reduce 2/4 to 1/2, and x minus 3 over 2, that reduces, and then after reducing, you bring the bottoms up, because they can't divide anymore. So you get 2x minus 1, 2x minus 3. I am a pro for being able to make that problem up so fast. So I'm saying that could happen to you, wherein you have some kinds of numbers here that don't divide, but they could reduce. It could be one of them that reduces, or maybe both of them need to reduce. If they need to reduce, you got to reduce them. Notice the front number was 4x squared. That's only possible. Well, it could sometimes be 4x on one and 1x on the other, but in this case, 2x and 2x makes the 4x squared, right? And those happens when something reduces usually. So be careful. That did not happen on this earlier problem, unfortunately, so I wanted to show you one where it could happen. Okay, that was a total aside, an extra problem. Let's go on to the next one. We got u squared minus 8u plus 16. Now, this is a special case, but if you don't recognize that, just do the normal three-party thing. Well, multiplies makes 16, but adds up to negative 8. Well, that's a negative 4 and a negative 4. So the answer is u minus 4, u minus 4. Or, if you have it, you can write u minus 4 to the second power. If you, on Alex, at least on the reviews, if you write u minus 4 and u minus 4, it'll give you a little message saying you could write it to the second power. On the test, it'll be fine for either answer. Now, if you want to do it as a special case and save the smallest amount of time, you should look to yourselves and be like, okay, 4 and 4 make 16 and 4 and 4 make 8. So if that's the case, you just have to choose the right sign. In this case, the middle thing's negative, so both 4s are negative. I'm trying to like glaze over that because honestly, I'd say you should just do it normal. Okay, the next problem is rough. It's not normal, and I saw a lot of people struggling with figuring out how to split something like this when it came to factoring it on the recent test. This has got two things. You can't divide something out of 49 and 25. And I had everybody going, I can't divide something in common out of those. You're right, okay? So here's what you do. First, you recognize the following, that 45 is 7 times 7. And you recognize that 25y squared is 5y times another 5y. And there you go. Now you just plop them into some answers. Ready? 7 plus 5y. There you go, part of the answer. And 7 minus 5y. It's very important that one's a plus and one's a minus. Doesn't matter the order. But the plus and the minus of the same stuff cause there to have been no middle term, and that's why this thing only had 2 terms. Now, if you're absolutely insane, you could do the following thing. You could do 49 times 25 and write what that is on top. What is 49 times 25? Math. Hold on. 100, 1250. Okay, 1225. That's what you get on top. That's such a dumb number. And on the bottom is 0 because there's no middle term, so the middle term is 0. So you can ask yourself, what multiplies and make 1225 and adds up to 0? The answer to that question is positive 35 and negative 35. At least I'm pretty sure that's what it is. Am I crazy to say that? Desmos? Desmos? First of all, let's check my math. Hey, look at that. And does negative 35? I don't know why I'm doing it positive and negative. Whatever. Oh, would you look at that? It makes... well, hold on. This was technically a negative sign. Would you look at that? I was absolutely right about that. And those would add up to 0, of course. Now, are you going to notice that? No, that's a very big number. It's very difficult. How did I get 35 so easily? Well, I knew this was 7 and this was 5, and a 7 and a 5 make a 35, and that kind of works out like that. Now, you wouldn't even be done here. You'd have to do like bottoms up or something. You'd have to do like, how to even describe what I want to say here? You'd have to do 35 minus y. No. This is so bad. You'd have to do y minus plus 35, y minus 35. You'd have to put each of them over 25, because that was the number in front of the y squared term. Then you'd have to reduce it to 7/5 and negative 7/5, and then bring the bottoms up and get 5y plus 7 and 5y minus 7. But guess what? That's still wrong because the minus has to be this way. It can't be 5y minus 7. Guys, do not do what's going on the right over here. Don't do that. Look at this. Hold on. Let me get my red out here. Let me get this right here. Don't do that. Just recognize that when you got two things, that's very likely to be this quick situation. Just go right to the answer. That's all you got to do. All right. Enough of me complaining. I just really want to describe that because I felt like a lot of people had forgotten that special case. And if you just sat there watching me rant about how to solve it, well, now you're going to know better. We made it. Problem 36. What time are we at? 27 minutes. This is a long video. But I was talking about stuff for a long time, and I have the potential to potentially cut out 2 or 3 of the questions from this, as I do recognize that this may be a little difficult for some of us. Or time constraint wise, I think you should be able to answer the questions, but I don't know if you'll be able to answer this much questions in a class period. No promises. All right, this one. Just like problem 18 from earlier, we need to factor something out of all of these. Everything's divisible by 2. And everything's divisible by w to the 5th. Notice I'm always choosing the thing that was the least of in terms of exponents. So my answer will become 2w to the 5th. And then the leftovers here are 5w squared, after I remove this stuff, negative 16w. And at the end we get plus 12. Very important that's plus 12, not 12w, because 5 and 5 cancel out completely. Now, I saw people putting stuff like this on the test, and this is a good start, but this is not the end. Could the leftover things in the parentheses here be factored more? Yeah, gotta try it. Pretty sure it can. 5 and 12 multiply to make 60. Well, multiplies to make 60, but adds up to negative 16. That's a negative 10 and a negative 6. That's a tricky one. Anyways, the result here is that you get w minus 10, w minus 6. You have to put each of them over 5. I'm using the bottoms up method here. I get w minus 2 and 5w minus 6, as this one has to go up. That's not the answer though. See this 2w to the 5th? That's been here all along, so make sure that continues to be part of the problem. So my final fully factored form, if you watched that and got the joke, good job, is 2w to the 5th, w minus 2, and 5w minus 6. Fully factored. And fully incorrect. What did I do wrong? Wait. Oh, no. What did I do? Uh-oh. Uh-oh. We got to review it. Oh, I'm so stupid. Look at this crud. I put 12 over here. I did 6 times 2, not 6 divided by 2. Gosh dang it. That's going to cause a problem. If you were watching in the middle of this problem and went, oh no, he's doing it with the 12, and he shouldn't have. Ah, heck. Ah, geez. Okay, this is going to cause a little bit of a problem here. Numbers are changing. Ready? Here we go. Change number 1. We now have 15 on top and negative 16 on the bottom. It's very unfortunate that those numbers worked out before. Anyways, negative 15 times negative 1. Okay, we're going to make this negative 15 and negative 1. Okay, 15 divided by 5 becomes 3. And 1 cannot be divided, so this 6, that was there. That was never there. I don't know what you're talking about. That was a 1 all along. All right, just a quick little bit of this, a little bit of that, and now we're good. Oopsies. Don't do a boo-boo. 6 times 2 somehow happens to the best of us. Man, that's it. It's going on my math permanent record. All right, well, it was corrected. I know on the test I don't get a second shot at it. If it was me taking a test, I would have gotten 35 out of 36. Hey, which is not bad in 96, right? All right, that being said, do that one very carefully if you get that one. Make sure you divide out what you can. Whatever's left over, you might need to factor. You might need to make an X. Do the bottoms up. Carefully do it all, by the way, and keep that number you divided out in front of everything at the end. All right, we covered a lot here. I don't want to make the video run on too long, but problems 18 through, hey, look, 2 hours and 45 minutes. Okay, well, that's because I took a break after the first video and left it open. That was part 2. That was all polynomial stuff. We had the following things. I guess I should go to the report real quick. On the last one, I kind of showed you guys off what it was. Problem 18 was about the degree and the leading coefficient. Problem 19, 20, 21, 22, 23, 24. There was a lot of them here. 25. Yep, still going. All of those were distributing polynomials, combining polynomials by adding them, mostly multiplying a binomial by a binomial, 2 things by 2 things. You got to do FOIL or use the box. Okay. Then after that, 26. Let's see what we had here. We had special case of multiplying. 27, we had special case of multiplying. And then we got to 28, where we started needing to factor stuff. So you divide stuff out to the front. We had 4 things. Factor by grouping. We had to use a box on that one. 30, 31, 32, all those ones we had to like draw the x, figure out what multiplied to make this, added up to make that. On these later ones, it was a special thing because it had that number out front. So we had to do like 2 extra steps, the multiplying the first and the last, and then doing bottoms up on there. Oh, sorry, trying to show you on here. Multiplying the first and last, doing the bottoms up and stuff like that. And then it all culminated with 34, 35 special cases, and 36, this beast that defeated me. Oh no. All right, anyways, there it was. Well, we corrected it though. I know that wouldn't happen on the test, although I would be very impressed if you accidentally made 12 and then still worked it out and did something with it. I would be impressed by your knowledge enough to probably give you some points back on that if that was your situation. All right. Enough of me. That's enough video. So I hope this video was helpful for you and it helps you A, complete your review, and B, help you become better prepared for the midterm, which may or may not have as many questions as this part of the review. We'll see. We'll see. No promises. No 100% promises. All right, that's all I got to say, and I will see you guys on the next video. Bye.